Hello, good evening all.
Good evening,
Good
ma'am.
evening.
I already see one message over here. Is there any Android app from where we can make .txt file for AMQs? I'm sure you can find a lot of online.
Ma'am, sorry, ma'am, I just joined. Can you repeat what you said?
No, someone has asked in the chat if there is any Android app from where they can make .txt file for AMQs.
Okay, ma'am. Ma'am, and in the last lecture, you have mentioned about some book. Can you write the name of the book, please, ma'am, in the chat box?
I forgot which book it was, Sheldon Roche.
Ma'am, I didn't attend the lecture, but I got to know about it.
Um, I think I would have mentioned Sheldon Roche. I will write it in the chat.
Yeah, ma'am.
So it's by Sheldon Ross. The book will be probability and statistics, maybe. Just search. It's quite very popular book. You should
Ma'am, in
be
this book,
able to find
there
it.
will be, sorry, ma'am. Ma'am, like combination and permutation concept will be there in this book, ma'am, for
Yeah,
practice.
it will be there. It will be there.
Okay, ma'am.
Yeah. All right. So today is week 7. So have you watched week 7?
No, ma'am, not yet.
Not yet.
Yes, ma'am. Yes, ma'am. I watched the lecture probability. That's probability. Oh, by the way, good evening, ma'am.
Yeah. Good evening. So the deadline for week 7 is Wednesday. So you should start watching now because this weekend is anyways Diwali, then a lot of festivals are there. So you should be watching the lectures, no?
Ma'am, on Diwali, there is a class on stat.
What?
On the Diwali stat class is on Diwali.
Oh no, it will remove it. It's not, it won't be there.
Okay, ma'am.
Okay, I'll share my screen. Can you see my screen?
Yes, ma'am. Yes, ma'am. Yes, ma'am. Ma'am, I have doubt in mutually exclusive
Mutually,
and disjoint.
mutually exclusive and disjoint.
Yes, ma'am.
Okay.
And in Venn diagram also.
Venn diagram also.
While doing the questions solving, I face the problem in this type of concepts.
First, let me write down what all topics
Yes, ma'am.
are there in week 7. So week 7 is very basic, it's very easy.
Yes, ma'am. It's easy.
Is happening. Oh, I'm not able to write. Wait, just give me a minute. I'll share it. Okay. So the topics that we are going to cover in week 7 is first is what is random experiment? Then you will look at sample space. Then you have events. For sample space, you will also look at outcomes. Then you will understand what is probability. There is Venn diagrams. Then conditional probability. Is conditional probability in week 7?
No, ma'am. It is in week 8.
Okay. What about independent and dependent events?
Independent.
I think that
No,
also is not there.
yes, ma'am. It is also not.
So these are the things that you're going to look at.
Union and intersection is there.
Okay, union and intersection is there.
Yes, ma'am.
Ma'am, equally likely outcomes.
This also equally likely outcomes.
Addition rule of probability.
Yeah, all that will come in. I will not write.
Probability.
Just
Yeah.
we will discuss it.
Disjoint.
See, so in this week 7, you are going to mostly talk about the probability. And before we move to what is probability, it's more like there are various terminologies that you need to understand. So in probability, it's more like it's more like chance. Like you would have always heard, like if there's some election, what is the chance that party A wins the vote, right? Something like that. You have some election in your college, and there you want to know which group is going to win the election. Or let's say if you are solving some MCQ problem, like you always have like whenever you write an exam, you may come across multiple choice question, right? You would have seen in your qualified exam or your first one, whatever it is. So you will see MCQ question. So what is the chance that a particular option is right there, right? So all these things, or what is the probability that when you toss a coin, like very simple example that comes in the probabilities, coin tossing, rolling a dice, cards. These are very frequent questions that come in probability. So we will look at before going on solving such kind of problem, we'll look at what is experiment, what is random experiment, or what are the outcomes, and so on. Okay. So first of all, what is experiment?
As
Ma'am, the process in which
tossing
we
the
look
coin.
observation.
As tossing the coin.
Experiment
Sorry.
is like you would have done the experiment in your physics or chemistry lab or biology lab, right? You do some experiment there, and from the experiment you are trying to get some outcome, right? Or some observations, whatever. So it can be extended to, like, this notion can be extended to multiple things. And so experiment is nothing but any process from which you're expecting an outcome or some observation, right? But and that was experiment. But what is random experiment? Random experiment is something for which you are not sure about what the outcomes are going to be, right? So when we say what the outcomes are going to be, I mean, there is uncertainty in, like, for example, you are tossing a coin, right? So tossing a coin. Beforehand, you don't know whether you are going to get a head or you're going to get a tail. So there is randomness in this. There is randomness in this experiment. So such kind of experiments are called random experiment, because you will not know the outcome of these experiments in advance. Also, let's say rolling a pair of die, rolling a die. So again, what are the outcomes you can get? So okay, when you're tossing a coin, or possible outcomes can be head and tail. When you're rolling a die, you can either get a 1, 2, 3, 4, 5, 6, right? So
Yes,
these are
ma'am.
the outcomes you can get. Very simple example. And when what we have written here is outcome. So whatever result you get from these random experiments, we are calling them as outcomes. So all this head, tail, these are outcomes. 1, 2, 3, 4, 5. All these are outcomes of these random experiment. Now, the next question is, what is a sample space? Or okay, before we go to like sample space, let's say we have talked about tossing one coin, right? But when we toss two coins, what are possibilities you have? What are the outcomes you will get?
Head, tail, and tail, head, like this.
Yeah, so you will have either, so you have, of course, you should have two places.
Yes,
So
Yes,
ma'am.
ma'am.
first place can take either head, or second can
Head
also,
or head.
first place can take head, second can take tail, third can take tail, for second can take head, or both can take tails, right? So these are the four possibilities that you can have. Now, for example, just extend this to rolling a die two times. Now you're rolling a die two times. So can you tell me what all outcomes you can have?
1, 1, 1, 1, 1, 2, 1, 3, 1,
You will
4,
have,
like this.
yeah, so
36.
you will have total of 36 outcomes. I'm not going to
36
write it.
sample
It
space.
will take quite a long time. So you know, I mean, there will be 36 outcomes, because one can come with 1, it can come with 2, it can come with 3, it can come with 4, it can come with 5, it can come with 6. Similarly, 2 can come with 1, 2 can come with 2, and so on. So for each of these outcomes, we have 6 possibilities. So this is just 6 square. Right? So you get 36 outcomes. Okay, now let's move to sample space. So what is sample space? So sample space is the collection of all the outcomes of a random experiment. So this is collection of all the outcomes of a random experiment. And it is usually denoted by either sigma. So this symbol that you see here, this is called sigma, or S.
That sign is omega.
Omega, no? Yeah, when I thought so, I'm saying something wrong.
Yes,
Yeah, so
ma'am.
this is omega.
Yes, ma'am.
The one. So there is two omegas. One is smaller one. This is a bigger omega. Yeah. Yeah. Okay. Thanks for correcting. So usually we denote the sample space using these symbols. I mean, it depends on you what symbols you want to use. There is no such restriction, but generally, whenever you solve, look at various textbooks, this is a standard notation that many textbooks use. So it's okay, whatever you use. So
We
sample
use
space,
S.
yeah, S is good. So sample space is just a collection of all the outcomes of a random experiment. Now, okay. So when you take the example of tossing a coin 3 times, tossing a coin 2 times, what is the sample space?
1,1, 1,2. This
No,
is
no,
sample space.
I'm talking about tossing a coin 2 times. Can
Means,
you give the sample space?
head, tell, head, and tell.
Yeah. So you have,
Ma'am, head, tell,
yeah,
head.
yeah, yeah. Tell,
Tell.
right.
Yeah,
So this is the sample space, right?
yes, ma'am.
So in the lecture, you would have seen the sample space for even the continuous cases. Let's not go there for now, maybe because you have not looked into continuous random variable so far. So let's stick with the discrete random variables. Okay. Now the next is, what is an event? So event is any collection of the outcomes. So
Event is a subset of sample space.
yeah, that also you can say. So event is a subset of your sample space. Much better. So whatever, so for example, in the coin toss case, you have the sample spaces HH, HT, TH, TT. So how many events can you define? So I can also define event as, let's say, E1 to be 5. Right? So, okay, when you say subset of your sample space, or let's go with a much simpler example. Let's say I am talking about just one coin toss, right? So you have head, tail, head and tail. Now, can you find the subset of the sample space?
Head, tell, and head.
One can be 5,
Yes, ma'am.
one is just H, one is just T, one is the whole sample space, right? So these are the subsets, possible subsets for the sample space, and I can define my event to be any of it. So depends. Let's say what I want to know, what is the probability of occurrence of a head. So my event is probability that E1, let's say, equal H, or this, right? I can write this. This is probability of one head. So these define the events. Now, if you go to the two coin toss experiment, so you have HH, HT, TH, TT, right? So let's say I want to know, define the event such that you have yes, define the event where head occurs on the first outcome. So in that case, you will have both HH and HT, right?
Yes, ma'am.
Yes, ma'am.
So if you're interested in knowing, if you can also define like both event as both tails. You can also define event as tail on the second toss or head on the first toss, right? So all these events are possible.
And we can
So
also
depending
fix
on,
head on second toss.
yeah. So it like whatever is asked in the question, accordingly you can define your event.
Ma'am, can you repeat that how headed and head tail came? Sorry, ma'am.
What I said is, let's define the event as head on the first toss. So if I'm talking about head on the first toss, so you look at the sample space only for this outcome and this outcome, head is occurring on the first toss, right? So that is why it is HHHT. Is it okay? Is it okay?
Yes, ma'am.
Okay. All right. Then now we saw what events are. Then you also have union of events or union and intersection of event. I will just do together. Union and intersection of events, right? So what is union of events? So let's say I have an event, let's denote it as E1. Let's say event 1 is contains A, B, C. Event E2 contain B, C, B, C and D. Okay. So now if I have to write E1 union E2, so
A,
E1
B, C,
union
D.
U2 means the union of both these events. So whatever outcomes are there in event 1 and event 2 must come to this union of these two events, right? So in event 1, so basically you have to combine these two and you should take care that all the outcomes that are there in these events should come in your union. Okay. So even union U2, it is A, B, C. And again, if you look at event E2, your B and C are already there in E1. So I can skip it because now we are talking about a set, right? And in set, we don't repeat any element. So I can just write A, B, C, D. That will give you event, a union of these two events, E1 and E2. Then there is something called intersection. So intersection means you have to find something common between these two events. So what is common in these two events? It just B and C.
B
Right?
and C.
So you have B comma C, right? So if I give you any two sets, you should be able to write union of two events and you should be able to write intersection of two events. Okay.
Okay, ma'am.
All right. So for example, the event that we defined, let's say, let's say define E1 to be head on the first toss, E2 to be tail on both the tosses, then can you tell me what will be E1 union E2 and E1 intersection E2?
Ma'am, E1 union E2 is equal to HT
HT.
and E1 intersection E2 is equal to T.
What?
Phi.
Intersection phi. Intersection phi.
No, I'm asking, first tell me what is E1 union E2?
It would be
H
HT,
H T
and
T
T2.
T T H.
H.
TH, why it will be TH? It is just 3 elements, right?
Yes, ma'am.
And what is E1 intersection E2?
Phi.
The one there would be
Phi
an
is
HH
phi.
also. HT, HH, TT.
Hmm.
HTT ma'am, not HTT.
What?
Even
The union, it would be HT,
HH,
HH, and TT.
HTT.
Hmm. Oh,
STHH. HH, ma'am.
got it. Yeah. Okay.
Yes.
Now there is, you saw what is union of two events, you saw intersection of two events. Then there is something called null event. So any event that has no outcome, I mean, the outcome is phi. The event in which the outcome is phi, you call such event to be null event. So you can take the example as okay. For example, let's say E1 is H, E2 is T, then E1 intersection E2 is phi,
Right.
right?
Phi,
So
ma'am.
this is an event that has no outcome, right? So such events you call it as null event. So in this case, intersection of E1 and E2, this event, so this is an event, okay? So E1 intersection E2, this event is a null event, right? Now, what is disjoint event? So if the intersection of two events comes out to be phi, then in that case, we say these two events are disjoint. Disjoint, or also it is also called mutually exclusive. It has another name, it's called mutually exclusive. Okay. So if E1 intersection E2 is phi, then we call E1 and E2 are disjoint. Because if these two events are
Ma'am,
hmm,
then null event is also disjoint
what is disjoint?
as you written upward. E1 intersection E2 is equal to phi.
So yeah, even in this case, E1 and E2 are disjoint. So we will say, since intersection is phi, we will say E1 and E2 are mutually exclusive or disjoint. Right? That's all. Now you have complement of an event. So let's say you have an event E which contains, or not, just don't start from, okay. Let's say the example is tossing a coin, tossing a coin, tossing 2 coins, okay. So sample space is HH, HT, TH, TT. Let's define an event E1, or let's say E, to be HH. Okay. So the complement of this event is given by S minus E. So whatever is there in the sample space, if you remove whatever is there in your event E, that will give you E complement. Okay. So what is E complement in this case? It is HT,
HT,
TH,
TT.
TT. Right? Now, general case, like if I have to take the complement of the sample space, what
5.
this will be 5, right? This will be
5.
null event, null set. This will be null set. Now you have subsets.
Ma'am, I have a question. That are all null events the disjoint events?
What?
Are all null events the disjoint events?
What do you mean? A null event, disjoint event? I didn't understand.
Like, ma'am, in the first case, like you explained about, in this case, like you explained about sample of complement, sample space complement. So it is a null event. So it is is it a disjoint event as well?
No, I mean, you say, see, when you say an event to be null event, it means you're talking about just one event. I mean, I am giving some event. So in this case, the event is S complement, sample space complement.
Yes,
Right?
ma'am.
This is the event. And this, since this is phi, we are calling S complement as a null event. Okay.
Okay, ma'am.
But when you have to say disjoint, the disjoint events or mutually exclusive events, so disjoint with respect to what? So you need to have some two events, then only you will say, okay, I have an event T, I have an event F, and now if I take the intersection of these two events, I am getting the intersection as phi. Because there is no, and saying that, it means there is no element or outcome that is common in both sets.
Okay, ma'am.
Right? Then you say
Fine.
even E and F are disjoint or mutually exclusive.
Okay, ma'am.
Okay. Now you have subsets. So subsets is like, okay, consider any set. Okay. So consider any set. Let's say my set is 1, 2, 3, 4, 5, 6. So what are the subsets of so let's say I'm taking a subset, I can call it as, let's say S1. S1 is a subset of S. So this S1 should contain the elements which are in S or less than S, right?
Yes.
Right. So
Yes, ma'am.
I can define this S1 as, let's say, this one is my subset, right? I can define subset to be 1, 2, 3, 4. This is also my subset of the sample space S. I can define my subset to be the whole set. This is also a subset. Right? So in terms of events, let's say if I have two events, E and F, or let's say two events, E1 and E2, So we'll say E1 is a subset of E2 if E1 contains all the outcomes that are there in E2. Right? If all the outcomes of E1, if all the outcomes of E1 all the outcomes of E1 are also in E2. Right? All right. So next topic that you have is Venn diagram. So Venn diagram is any graphical representation. So Venn diagram is just to represent the events or the sample space graphically. So generally what we do is the sample space, we denote it as a rectangle S. Okay. This is what we use. So let's say this rectangle is my sample space and any event that I take is going to be some circle. Okay. So let's say these are my events in the sample space. So you are denoting S, the sample space, as a rectangle and events as circles inside the rectangle. Right? So for example, let's say I want to, you have two events, E1 and E2. Now you want to illustrate what is E1 union E2. So this is my sample space. I have an event E1. I have an event E2. E1, E2. And I want to know what is E1 union E2. So E1 union E2 will consist of all the outcomes which are there in which is there either in E1 or is there either in E2, right? So this is the shaded region. Right? This is fine. This is okay, no?
Yes, ma'am.
Okay. Now, what about E1 intersection E2? Like if you have to mark E1 intersection E2, what will you do?
We shaded the common part between
The
even
common
and E2.
part, because when you're talking about intersection, we want the outcomes which are there in both E1 and E2. And something which is in both E1 and E2 is just this area. Right? So this represent E1 intersection E2. And this blue region combined represent E1 union E2. How will you represent the disjoint events?
They'll have no intersection there.
What?
No intersection or red part will be there.
Separate events.
Yeah, they will be non-overlapping. So let's say this is E1, this is E2. So if you see Venn diagrams like this, I mean, you can easily say that since their intersection is null, these two events are mutually exclusive or disjoint events. What about
Yes,
subset? What about subset?
Set inside a set.
Yeah.
even inside E2, ma'am, even inside E2, like is a subset.
Yeah. So if I am going to talk about E1 is contained in E2, so it means, let's say if this is my E2, my E1 should be inside this, right? Correct?
Yes, ma'am.
Yeah. Now what is, look at this figure. Can you tell me what is E complement? Sorry, E1 complement. What is
Ma'am,
E
the
complement?
the elements which are outside E1, that is E1 complete.
Yeah, so this whole thing, right? This whole thing is going to be E1 complement, right?
Yes, ma'am.
And E2 complement will be all this. Right?
Ma'am, can you please explain this again?
Okay.
Yes, ma'am. One time.
Okay.
Disjoint one also, please, ma'am.
What?
That just disjoint Venn diagram.
Disjoint Venn diagram. Okay. Uh, see, these two events. So this is my sample space. Let's say this is my event E, this is my event F. So when you look at these two events, you see that there is no common element, right? Their intersection is phi, right? So whenever the intersection of two events are phi, what do you call them? You call these two events to be either disjoint events or mutually exclusive events, right?
Ma'am, if even in E and F, if touches, then also be a disjoint.
What? If E and F are?
Ma'am, if E and F are touches, both circle are touch to each other, then also be a disjoint set.
Then in that case, we are not sure, no? I mean, we are not sure because you are saying even if one point touches, we don't know, right? In that
Ma'am,
case.
complement. C
Yeah.
complement means
What?
compliments, ma'am. Actually,
Compliments, yeah. So, okay. See this figure. Now, can you tell me what is E complement? So, first of all, what is E complement? E complement will be the sample space minus the event E. So, this whole rectangle is the sample space.
yes, ma'am.
This whole rectangle is the sample space, and this circle, let's fill some color. So this circle is your event E, the circle marked in yellow. Now, the whole rectangle, from this whole rectangle, if you subtract the circle E, then you will be left with all
Okay.
reason, right?
Yes, I am understood.
All this reason. So this whole thing is E complement, right? Right.
Yes, ma'am.
Yes, ma'am.
Okay. What else is left? Now you have probability.
Ma'am, there are three probability axioms.
Yeah, so there are three different interpretations of probability. So one is given as the classical approach. So classical approach. So it's mostly theoretical. So it's like you are given a sample space. You perform some random experiment. For this random experiment, you have a sample space, and in that sample space, let's say all the outcomes are equally likely. So yeah, somebody had asked what is first of all equally likely. So let's see that first. So equally likely means let's say in the sample space, let's say these are the outcomes, okay? Or let's write 1, 2, 3, 4, 5, 6. So this, let's say I'm taking the example of rolling a fair die. So there, like if you roll a fair die, what is the chance that you will get a 1? So that is nothing but this you're talking about just one outcome. So it is 1 divided by total number, right?
6.
So total number of outcome is 6. So again, what is the probability that, what is the chance that when you roll where did it go? It got deleted, is it? Okay. So when you so what is the probability of occurrence of 2? So it is again 1 by 6, right? What is the probability of occurrence of 3? It is again 1 by 6. For 4, it is again 1 by 6. For 5, it is again 1 by 6. For 6, it is again 1 by 6, right? So you see that in this sample space, all the outcomes have a probability of 1 by 6, right? So this is what you call it as equally likely. It means every element are equally, the chance that this outcome comes is equally likely for all the elements. I mean, equal for all the elements. Are you able to understand this?
Yes, ma'am.
Yes, ma'am.
So this is what we mean by equally likely. And the first and our first interpretation of probability that is given, which we call as a classical approach. So there we are talking about you have a sample space for any random experiment, in which let's say in which you have n equally likely outcomes, and you define an event E, any event E. So define any event E. It consists of, let's say, some for example, this case, let's say I take 1, 2, 3. So what is the probability of event E? It is just going to be 3 by 6, right? Correct? Because your sample space was 1, 2, 3, 4, 5, 6. And what we are saying is all the events, all the outcomes are equally likely. right? Because the probability of occurrence of any of these outcomes is 1/6, correct? So now if I define an event E, which is some subset of S, then probability of this event E is just number of elements that are there in E divided by total number of elements that are there in S. So this you can write as number of outcomes in E divided by divided by total outcomes, right?
Yes, ma'am.
So this is the first approach. This is the first interpretation of probability. Then the second is you have the relative frequency approach. So there what you do is, so there to talk about proportion, like for example, we say 9 out of 10 candidates have passed the exam, let's say. Okay, so there it just the fraction, you take the frequency there. So it would be 9 divided by 10. That would be your probability of winning. Sorry, probability of passing the test. But this we generally don't take for small things. It mostly happens for something which has been happening from a long time. Okay, and such experiments have been repeated quite a many times, and then you say then in that case you talk about the relative frequency.
And can you please repeat this relative frequency probability?
Yeah, so this is given as this is proportion of times event occurs in a long time. What is the simplest example I can give you? You can take this maybe coin toss experiment, right? So how did you say that if I toss a coin once, I should get 1/2? So someone has done, I mean, you do the experiment repeatedly some n number of times where n is quite large, then you will see that the proportion of times your head has come is 1/2, is 0.5. So something like this. So this is one approach for probability that we say. Maybe mostly you will be dealing with the first approach that we have seen, the classical approach. And these things are very theoretical, this relative frequency and the next one that we're going to see, they are very quite theoretical. Maybe right now it's not needed for you, but the classical approach is what you're going to use it a lot in this course. Then next is subjective, the subjective interpretation of probability. So this is just like your opinion, like what is the best guess to say, right? It is more like somebody asked you, like, what is the probability, what is the chance of this event, that this event will happen. So maybe you do something and this is the best guess you are able to come up with. So that is also a probability, but it's quite subjective. I mean, this is what you have been able to come up on a conclusion. So it's like, what is your opinion? Like when we toss a coin, I mean, you can say the probability of occurrence of head is not 0.5. You're free to choose that, right? So such things are like, whatever your opinion is on any event that is happening, and if you are able to give a probability on that such kind of probability is subjective.
Ma'am, is subjective and classical probability, ma'am, are same or different?
No,
Because in both we get
in
opinion.
classical, it's not in your opinion. I mean, we are saying that in the sample space, all the events are equally likely, all the outcomes are equally likely. And now we are defining an event, and now we are finding probability of an event. And probability of an event is nothing but number of outcomes that you saw in the event D divided by total number of outcomes. But in case of subjective, it's your belief. I mean, you are not doing anything. It's your belief. Like maybe coin toss is a very simple example. It may not reflect the idea much, but the subjective cases, like you may have, for example, take the case of election. So you may say that okay, this
Ma'am, the
candidate,
probability of winning any party.
yeah, this part is going to win. So that
Ma'am,
is also,
in classical, we assume all events are equally likely, but in subjective, we can't assume or we not assume
yeah,
any
you are not
equally likely.
assuming anything. Whatever you think, I mean, whatever you think whatever you are guessing, basically.
Yeah.
Yeah, it's your belief that this can happen for this event. No, things like that.
Yes, ma'am.
Okay. So now we have various axioms of probability. So there are three axioms of probability. So one is, for any event E, probability of an event will always lie between 0 and 1. Okay. Probability can never lie outside this interval 0, 1. Okay. So probability of any event is always between 0 and 1. Now the second is, probability of a sample space is 1. So if you take any, I mean, you have some random experiment, you have the sample space for that random experiment. And if you want to know the probability for that sample space, that is always going to be 1, because you are saying this is always coming. So the probability is always 1, right? So that is the argument you can give. Now the third is, if you have a sequence of mutually exclusive events. So before we saw what is exclusive events, but just for 2 events. Now, so now what we are saying is, let's say you have mutually exclusive events, E1, E2, up to, let's say, En. So when we say these events are mutually exclusive, it means that their intersections, E1 intersection, E2 intersection, En should be pi. Okay. So you take a sequence of mutually exclusive events, then probability of union of these events. So when you say union of these events, it is just probability of E1 union E2 union E3 and so on. And this is given by probability of E1 plus probability of E2 and so on. And in short, you can write this as probability of EI, I varying from 1 to infinity. Let's not stick to some n. I'll just write this. So It can go to any number, so I'll just write it infinity. So these are the three axioms of probability. So first is probability of any event always lie between 0 and 1. Probability of your sample space is always 1. And the third is if you have a series, if you have a sequence of mutually exclusive events, then probability of their unions is going to be summation of probability of these events. Okay.
Ma'am,
So
can you please repeat the mutually exclusive event once again?
mutually also okay. So when we are saying E1 and E2 are mutually exclusive, okay, then what do we mean? We mean that E1 intersection E2 should be phi, right? No. Now, if you have a sequence of mutually exclusive events, so what we're saying is, now let's say we have not 2 events, we have, let's say, 3 events, E1, E2, E3. And we are saying these 3 events are mutually exclusive. So it means that their intersection means E1 intersection, E2 intersection, E3 should be phi, right? And now if you just extend it, let's say you have many such events, and we are saying these sequence of events are mutually exclusive. It means their intersection should be phi. Okay.
Okay, ma'am.
All right. Now, so if you look at the third axiom, if I just take 2 events E1, E2, then we are saying probability of E1 union E2 is probability of E1 plus probability of E2. So what does it mean? It means if E1 and E2 does not occur together or does not occur simultaneously, then in that case, probability of union of these events is just sum of the probability of these events. Okay, I think that is all we had. Okay, addition rule is left.
Ma'am, these are disjoint, right?
Yeah, E1 and E2 are disjoint.
Okay, ma'am.
E1 intersection E2 is fine. Now, what is addition rule of probability? So, for any 2 events, E1 and E2, probability of E1 union E2 is given as probability of E1 plus probability of E2 minus probability of E1 intersection E2. This is for any 2 events E1 and E2. It need not, it is, we are not saying it is mutually exclusive. We are not saying that E1 and E2 should be mutually exclusive. It's just for any 2 events that you take, probability of union of these 2 events should be probability of E1 plus probability of E2 minus probability of E1 intersection E2. Okay. So that was all the theory that was given in your lecture. So any doubt in any of the theory?
No, ma'am.
Okay. I see something in chat.
Ma'am, we
Can you
have
please?
skipped one thing, ma'am.
What is it?
Probability of complement of an event.
Probability
It's
of
come under general property of probability.
Okay, okay. Hey, just these are properties that can be derived easily.
Yeah,
So,
ma'am. There is one formula, right?
so I mean, you don't need the formula, no? I mean, just see. So you have a sample space, you have an event E, okay? Now what you're saying is probability of E complement. So you know probability of this whole sample space should be 1. And if I want the probability of E complement, what this can be? It is just 1 minus probability of E, right?
Yes.
Yeah. So the theory is just what we discussed. Rest is all you can easily derive. Any other doubt from lecture?
Ma'am, can you please scroll up to relative probability? So, ma'am, can I write?
Yeah.
Ma'am, third one subjective. Can you repeat?
Yeah, subjective, as I said, no. So subjective is like your belief that on something. Like, what do you think as like who's going to win the election? What do you think like what do you think can be the chance that it is going to rain today? What do you think that the stock price is going to increase today? Right? What is the chance that you think the stock price is going to decrease today? So whatever you think is the best. So whatever guess you are going to do, right? So that guess, I mean, is your probability in that case.
Ma'am, it is more of an informal type of
Yeah, it's quite an informal thing. I mean, you're not talking about any numbers here. I mean, you're not doing any calculation, but just on like whatever knowledge you have and whatever situation is there right now, on that basis, you are just coming up with a answer, coming with a guess that, okay, this is what I think it can happen. Right?
Is it used somewhere?
What?
Is it used somewhere? Like
Is it?
subjective thing?
No, I mean, see, when you like when you want to know exactly the exact number, then you'll have to do the calculation. But the subjective, maybe you use it in your day-to-day life that you don't realize.
Yes, ma'am.
Yeah.
Hello, ma'am.
Yeah.
Ma'am, can you repeat the relative frequency probability and subjective?
Subjective, I just explained. So I will explain relative frequency again. So relative frequency is probability of any event. So you have some experiment. Let's say that your experiment is tossing a coin. Okay, this is the experiment that you took. Now, probability of any event. So let's say event you take it as occurrence of head, probability of occurrence of head. So in your coin toss experiment that you're performing, what is the probability of occurrence of head? So if you keep tossing the coin like n number of times or infinite number of times, so the fraction of times that event has come is going to give you the relative frequency. So let's say I coin the toss infinite, let's say 10,000 times or 1 lakh times, and from there I have observed um, the number of times my head has come. So you'll see that number is very close to 0.5 you will get. So such probabilities, you call it as empirical or relative frequency.
Ma'am,
Yeah.
Ma'am, you explained that E1 is equal to head on the first toss and E2 is equal to tail on both the tosses. I couldn't get that E1 intersection E2, how it came, ma'am. Can you explain it?
Yeah, where is it?
Yeah, ma'am, this
So
intersection part.
first write it in symbols. So head on the first toss. This is what? This is going to be head, 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 tail. Right? That's all. This event is just HH and HT.
Yes, ma'am.
Not tail on both the tosses. This is just one.
Yeah,
TT.
ma'am, got it.
Yeah. So first write your E1 and E2. And then only do your perform your union or intersection. Okay.
Yes, ma'am. Thank you, ma'am.
Yeah. Any other doubt you have?
No, ma'am.
Okay. Anybody else has any other doubt?
No, ma'am.
No?
No, ma'am.
So week 7 is easy. So
Yes, ma'am.
how many of you found week 7 to be easy?
Yeah, ma'am. Easy.
Yeah, ma'am, I found it easy.
It's easy, right? Yeah, it's quite easy. But these are the foundations that you're going to get when you move to the next weeks. So you should be very like these then events, the sample space, outcomes, random experiment, mutual exclusive, union, just like it will come very often. So you should be like very clear with the ideas, like what exactly it is.
Yes, ma'am.
Ma'am, the book you mentioned and practicing it and the practice assignment is enough for the week 6.
Yeah, it's more than enough. It has a lot of problems.
Okay, ma'am.
Anything else?
Ma'am.
Anybody has anything? Yeah.
Ma'am, can you explain some question on mix of permutation, combination, and probability?
Permutation, combination, probability. Okay.
Yes, ma'am. Addition rule also.
Addition rule too we did, no? Okay, you mean some problem. Some problem from addition rule. Okay, let's take the example from cards. Okay. So you know that there are total of 52 cards.
Yes, ma'am.
And
Yes.
in this 52 cards, you have
26.
13
4
of
suits.
you draw spade. I think it's like this. Maybe 13 of club. It's like this. 13 of heart. No. Yeah. And 13 of diamond.
Diamonds.
So the heart and diamond is red in color. So I've drawn in red. And out of these 13 cards, you have the numbers from there is no one.
Ma'am, can we interchange heart and diamond with clubs and a spade?
What do you mean interchange?
Color wise.
Color wise, no. I mean, you have seen the playing card.
Yes, ma'am.
Yeah. So the diamond and the heart is always red in color. Any card you take, it is always red in color. So there is no
Okay.
interchange. Yeah, okay. So any deck you take, let's say I'm taking a deck of spade. So it will have A, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And after this, you will have a joker, you will have a queen, and you will have a king. So this goes on for, like, this is same for all the deck of cards. Now let's say
One won't be there.
what?
One.
One won't be there. Instead of one, you will have A.
Okay.
So let's say the experiment is randomly selecting one card.
Ma'am, there is a 12 card.
What?
A to 10 maybe. You have write 9.
No, there is no one, no. So you have 10 over here and 11, 12, 13.
9 are there.
No,
A
you are missing A. You are missing A here. A is also a card, no. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, is it 12? What did I miss?
Maybe 10.
You miss 10.
Oh, I missed 10. Okay.
Yes, ma'am.
Thanks. Joker, queen, and king. Okay. Thanks. All right. So let's say your random experiment is selecting one card from the deck. So can you tell me what is the probability of doing it? How can you select one card from the deck of cards?
Then 1 by 52.
1 by 52.
1 by 52.
1 by 52.
1 by 52. Okay. Okay, let me take some problem. You want some problem which involves also permutation combination, right? Just give me a minute. Do you have any question? If you have question, you can give me, because we'll have to look for it.
Ma'am, can
Yes,
we
ma'am. I have.
discuss a practice assignment question?
Yeah, okay, that is fine. Okay, let me take from there then.
It's from week 7, ma'am.
7, yeah. Okay.
Yes, ma'am. In activity, there are lots of questions.
This is practice assignment 7.2.
Yes, ma'am. Question number 3, ma'am. Like, it's
Yeah,
sub questions.
that's what I'm taking the
90 students.
addition rule.
Yeah, ma'am, can we help to draw the Venn diagram?
Venn diagram, okay. Yeah.
Yeah, it's all about Venn diagram.
Questions. Okay. The question says there are 90 students who have participated in the annual cultural festival of a college. And this this annual cultural festival has either singing or dancing or acting. Okay. So students have participated in, these 90 students have participated in singing, dancing, and acting. What we're saying is number of students who did not participate in acting or dancing are 10. So let's make the Venn diagram.
Yes.
Yeah. This is sample space. So you have 3. Let's say this is for singing, this is for dancing, this is for acting. Okay. So total number of students is 90. Now, what we are saying, the first thing is number of students who did not participate in acting or dancing. So either in acting or dancing is 10. So it's mostly this. Right? So we are saying this is 10. This denotes neither acting nor dancing. Right?
Oh.
Now, number of students who participated only in dancing. Only in dancing is R15. So only in dancing is this. This is 15. Then you have total number of students who participated in the acting are 50. This whole thing is 50, right? Number of students who participated in both the singing and the acting. So both singing and acting, it means you have this are 20. So this is both singing and acting. Right? This oh sorry, I think this is wrong because you're talking about both singing and acting, right? So both singing and acting is this. Right? Fine. This is 20. Now, number of students who participated in both the dancing and the acting. So now look at dancing and the acting, and this is this is 15. The students who participated in all the 3 competitions are 10. So what is the shaded region where students participated in all the 3 events? What reason will
That's
you
center one.
the center? So this contains both singing and acting and dancing. And this is given as 10. Okay. So quite a lot of events to denote here. So the question that is asked is, what is the probability that a student selected at random participated only in the dancing competition? So this was quite easy because only in the dancing competition was already given that you have 15 students who participated. Right? This was given to you. So for the first question, for question number 3, probability that students participated only in dancing is 15. Total number of students who participated in dancing is 15 divided by total number of students, that was 90. So this should be your answer. Okay. Now, what's the second part to it? What is the probability that a student selected at random participated in both singing and dancing? So you want both singing and dancing. Probability of S intersection D. So you don't know the number for S intersection D, right? Because you don't know what is this unshaded region area, like what is the number for that? You don't know that, right? But somehow you will have to, you should be
Yes,
able to.
ma'am, there is 10.
There is given singing and dancing.
10.
No, that is 10 is 10 is what? 10 is singing intersection dancing intersection acting is 10. No. But
Okay, ma'am.
what about this?
Singing, intersection, dancing.
Yeah, you want this number to be also there, no?
Yes, ma'am. Okay, ma'am.
So how do you find it? That's the
Yes,
question.
ma'am.
Okay, let's see. So total number of students should be 15. Sorry, total number of students are 90. Okay. This is 10. See how 10 plus 15, these two we already know. This was how much? The screen is 20 plus 15. So this is 20 plus 15 minus this 10 will give me this area. And
Ma'am, we can take that
yes,
asking directly as 15, ma'am. If you take it as 50.
just hold on, We'll take 50 minus
Yes, ma'am.
what? 20 plus 15 minus of 10. This will give you this reason, this area. So what? 20, 35 minus 10 is 25. So this area is 25. And 15 plus 25. And this area is 25 again. You subtract it from 90, you should be able to get that. So 25, 50, 50, 60, 60, 75. 90 minus 75, how much? 15, no? Yeah, so 15 plus 10, it means 25. So you should be able to get 25 by 90. So I'll tell
Yes,
you
ma'am.
how
Correct.
I did it. Did anyone able to understand what I did?
Yes, ma'am.
Okay, good. So I just
Ma'am,
tried.
can you explain how did you get that, ma'am?
Yeah. So see, I already knew this black shaded region is 10. Okay, I wrote that. I knew already this red shaded region as 15. I wrote that. So if I could figure out what this blue shaded region is and what is this individually, this whole thing, and if I subtract everything from 90, I should be able to get this unshaded region in white, right? So to get this blue shaded region, I know this total is 50, right? So if I subtract if I subtract from 50, this and this green shaded region total was 20, this light blue shaded region was 15, but this 10 is what you are counting twice. So I need to subtract this 10 from here to get this region, right? So this is what I did. So this region is nothing but this is 25 total. So if you subtract 25 from there, this oh, actually somebody I think I did some, it was not needed. Okay, I think
Yes,
yeah,
ma'am.
it was not now I'm realizing it's not needed because we already know it's 10, it's already 15 and the whole thing is already 50. So you just add everything, subtract it from 90, you should be able to get 25.
Yes, ma'am.
Yeah. So this is just 25 by 90. Then the next question is, what is the probability that a student selected at random has participated in both singing and acting, but not participated in the dancing? Singing and acting, but not. Okay. That,
It is given to be 20.
It is given to be 20. Singing and acting. singing and acting, but not in dancing. No, that is not 20, no, because that also contains the dancing part. So it is more like, oh, it's not working. Okay, I just try it again. You have singing, you have dancing, you have acting. Singing, dancing, acting. This whole thing was given as 15. See, the question asks you to find someone who is interested in someone who participated in both singing and acting. So both singing and acting, but not in dancing. So basically this reason, right? And you know this this whole reason, I mean this whole thing is total given as 20. So you need to figure out what this is. That is already given to be 10. Right? So 20 minus 10 is going to give you 10. This is 10, right? This is total 10. And this total was 20. This total green thing here was 20. So 20 minus 10 is 10. So 10 divided by 90. Right?
Ma'am, can you explain the question of 4 again, ma'am?
Question number 4.
Yeah.
We wanted probability of singing and dancing. So singing and dancing
Means
is
how you have calculated that 25? I just
how?
wanted to know that.
See, singing and dancing, right? So singing intersection dancing is this reason. Okay.
Yes.
Now it is already given that this is this is 15. Okay. It is already given that
15 or 10, ma'am?
oh sorry 10.
Let's say yes, ma'am.
10. It is already given that this whole thing is 15. Okay. And it is already given that this total is 50. So this total is given as 50. Okay. And the question was, what is the probability that a student selected at random participated in both singing and dancing? So both singing and dancing, but we're not talking about acting, right? So both singing
Yes,
and dancing is just this reason that you see in blue color.
Okay.
So total was 90. You subtract everything from there, will give you that blue shaded region.
Okay.
Ma'am, your voice is not audible.
No, I'm not saying anything.
Okay, ma'am.
This is not right. What I just said. Okay.
Yeah, ma'am.
Yeah, this is not right. Singing and dancing, right? There is no restriction on acting. So this should be total this, right? This thing. This is what you are interested in finding. Okay. And see, you already knew that, and to find this, you know that this part, is 10. So you need to find only the blue shaded region. Okay? And that blue shaded region can be found as 90 minus 10 minus 10 plus 15 plus 15. And when you add these two, both the blue and the black shaded region, that will give you the total. I hope that is clear.
Yes,
Yeah. Okay. Can you suggest another problem?
Okay.
Ma'am, I have a question. Ma'am, there is the graded assignment in week 6 and there is EMQ type of assignment. So what should be the file extension or the file type for this type of assignment? Can you please tell me?
File type, I think all the information is already given in the portal.
Yes, ma'am, there is the CSV file and I have uploaded, but I have a little bit of doubt. That's why I'm asking.
Okay, can you tell me where exactly it is in week 7? I can check.
It's in week 6, ma'am.
It's in week 6. Hold on. So week 6, you have EMQ. Okay.
The graded one, and there is a test run button actually. So here the result is showing that the file format is expected, and out of 8 written, 0 answer have been written in correct format. So, ma'am, why it is writing that 0 answer is have been written in a correct format? Just because I have.
Hold on.
Okay,
Hold on. Yeah, if you say so many things, I'll just give a minute. Okay. So in EMQ, you have to enter the option as comma separated values. Enter the option as ascending order. The sample template file for answering. Please click here to download questions in PDF format. You want to check credit assignment. Okay. Can you tell me now?
Yes, ma'am. Actually, I have submitted the file, but I want to ask that is it only the CSV file? Just because I have uploaded the file and run the test button, but there is something showing in the result that 0 answer have been written in correct format. So I couldn't understand why it is written in this type.
0 answers have been written in the correct format.
Yes, ma'am. So
And you have to
I made the file, I mean the answer file as instructed in the previous one, like the as in the first here in the I mean the sample template as it is showing as the sample template showing here in the ascending order, and I made this and exactly the same type, but still it is showing that the 0 answer have been written in the wrong format, incorrect format.
I'm not really sure of this issue. Has anyone else done it?
For
Still
me,
not.
it's
Ma'am,
showing 50 by
I
100.
have, ma'am, I have done, but I am also facing this type of problem.
Okay.
Actually, the
due
test
date-
run score is showing 100 by 100.
Due date
But
today, right? For week 6.
yes, ma'am, it's today.
And you are already getting the marks, total marks, you are saying.
Yes, ma'am.
Oh. It is-
Test run score is 50 by 100 showing.
but it's credit assignment, no?
Yeah, ma'am.
So in this, what do? You have a list of questions. Okay, I'm not really sure what exactly you have to do here. You have to submit the answers for these questions, right? And you're saying you submit it in CSV file, is it?
Yes, ma'am.
So this instruction has been given to you earlier that you have to submit CSV file.
Yes, ma'am.
Okay.
Actually, I'm confusing just because the line that out of 8 questions, 0 answer have been written in correct format. That's why, ma'am, I am asking to you.
And what format did you use to write answers?
Ma'am, I use CSV format. As same as the template showing.
I don't think it should happen, or maybe since the deadline has not passed yet, you're getting something like this. I'm not sure. Let me check. I don't want to say something wrong here because I am not really sure of it. So did you put this on discussion forum by any chance? This course?
I think, ma'am, when I'm submitting the UMK file, ma'am, it's automatically running the test, ma'am. Test run.
Actually, support team mail.
No, let me check. I'm not sure what the issue is here. So you would have submitted this before also, right? Not just week 6.
Actually,
ma'am,
ma'am,
week
I
5 also.
missed the week
You have submitted it.
5.
Week 5, ma'am. Yes, ma'am.
I missed the week 5, and so this is for the first time I am submitting.
I'm not sure. I'm not sure. Yeah, maybe if someone else knows, can you clear his doubt?
Ma'am, we have got something new in our portal, weekly extra activity. What do we need to do?
Okay, on weekly extra activity, you need to it's like whatever you have studied in week 1 to 4. Now, let's say you want to implement it. Okay, so these extra activity are not they are not uh, as a part of your these total marks that you get, but these will act as a bonus for you. Okay, so it depends on you if you want to do it or you don't want to do it. It's okay, it's all up to you, but I would suggest please do it because it will give you to work with the actual data set and like to identify your data, to organize your data set, to identify variables, all that you should be able to do. So I think if you do the these activities, whatever you have studied, it will become a little more clear and maybe it will be interesting for you to.
Ma'am, which activity?
If you go on the portal, you will see extra activity section. Where is it? So you go to the portal, you go to supplementary content, not supplementary content. Weekly extra activity. Go to weekly extra activity. Go to portal, go to weekly extra activity. And there you will see that extra activity for the course, what exactly it is. So just go through it, see if you're interested to do it. The sample template is already given to you, like the way you have to submit, the way you have to answer it. So just go through it once before we discuss anything on it.
Does the EMQ have bonus marks?
No, EMQ is not for bonus marks, I guess. EMQ
It's only for practice.
part of, I guess.
Okay, ma'am.
Yeah.
Is the session over?
No, if you have anything to ask, please go ahead. In between, a lot of things came up. If you miss an extra activity, will it affect my scores? No, it will not affect your scores. This is an extra activity and it is something apart from your usual assignments that you do. So a total of 10 marks you can get extra if you do these extra activities. Maybe just try it out. It will be fun, I'm sure. Anything else? Yeah.
Ma'am, I have a doubt from week 6,
Okay.
tutorial 4.
Week 6, tutorial 4. Oh, week 6. Okay. Week 6. Tutorial 4. What is the tutorial about?
Brown dogs and black dogs, something like that.
Are now following.
You see the question. Are you able to see the complete question?
No, ma'am.
No, right?
No, ma'am. But
Can
I will. One second, ma'am. I will tell you the question. There are 4 black dogs and 16 brown dogs are running on ground such that no 3 dogs are in a straight line. Suddenly, 2 of the brown dogs started following one black dog, making a straight line, and the remaining 3 black dogs started following one of the remaining brown dogs. How many straight lines can be formed passing through the dogs?
Okay. How many black dogs did you say?
4, ma'am.
4. So black dogs is 4. Brown dogs
16.
16. No, okay, they are running on the ground such that no 3 dogs are on a straight line.
Yes, ma'am.
No 3 dogs are in a straight line, okay?
Suddenly, 2 of the brown dogs started following one black dog.
So when you say none of the dogs, no. Okay. Suddenly 2 of the brown dogs started following one black dog. Okay.
Making a straight line. And the remaining 3 black dogs started following one of the remaining brown dogs.
Let's say 2 of the brown dogs started following one black dog. Yeah, so it makes a straight line over here. Now remaining 3 black dogs started following one. What is that? Remaining 3 black dogs started following one.
One
Brown.
of the remaining brown dogs.
But brown dogs are 16, no?
Yes, ma'am. Means they started following one of them.
Okay, one
Any
of
one
the
of them.
remaining brown dogs. Okay. So you have 3 black, 1, 2, 3, and some one brown dog they are following. Okay. Now what? How many straight lines can be formed passing through?
Through the dogs.
Passing through the dogs.
Yes, ma'am.
But it also says no three dogs are in straight line. So these three dogs cannot be in straight line, no?
Yes, ma'am. They gave the solution like 20C2 minus 3C2 plus 1 minus 4C2 plus 1.
20C2. So, okay, first thing is we need to, the question is how many straight lines can be formed passing through the dogs? So you have to find the straight lines. So you need 2 points. So total lines that can be formed is, okay, 20C2. You need to choose 2 points, 2 dogs basically. So total dogs are 20. So 20 choose 2. This is total possibilities, but we also know that no 3 of the dogs should be on the same straight line.
Yes, ma'am.
You need to subtract something from here.
Yes, ma'am. Minus 3C2 and minus 4C2, then plus 2.
Minus 3C2. Out of the 3, you choose 2. Okay. What is 3 choose 2 plus 1 here? What is 4 choose 2?
That's why I couldn't understand.
I don't think I have looked at it. Let me just see it once properly.
Okay, ma'am.
Yeah.
Share the screen.
What? What are you saying?
Which question activities?
This is tutorial 6, sorry, week 6.
Tutorial 4, week
Week
6.
tutorial 4. Okay. So this is 3 dots. Okay. Let's see. Choose 2.
I have leave, ma'am.
What?
Leave class ended, no?
Class is over. If you you have nothing. Okay.
Okay. Good night.
Good night. Okay. Let me see this. I'm not sure. Who had asked this? Yes, right?
Yes, ma'am.
Yeah. Let's see it next time when we meet.
Okay, ma'am.
Okay, then. It's already done. We'll close the session for today. So if you have not watched the lecture, please go through it and solve your assignments. And happy Diwali to all of you.
Happy Diwali, ma'am. Thank you.
Thank you all.
Thank you, ma'am.